Hi all, welcome to Unit 3, Lesson 3. My topic for today is solving basic trig equations. So I want you to pause the video and try the warm-up on your own. Think of linear equations when you're solving this equation. Okay, so what is the question saying? It says solve the following equation for this domain. So x is between 0 and 2 pi. So what do? I'm going to subtract 1. So I'm left with rad 2 sine x equals -1. Divide by rad 2. So I have sine x equals -1 over rad 2. So I got sine x equals -1 over rad 2, which is same thing as what? Negative rad 2 over 2, right? You have to rationalize it. So first of all, I got a negative value. So where is sine negative? It is negative in the third and fourth quadrant. Sine is positive in the first and second, right? Based on our ASTC. So if you want to write that down, you surely can. So what is x equal to? For what values is x rad 2 over 2? It is actually that pi over 4 family. So it's actually 5 pi over 4 and 7 pi over 4. I can't go further because my domain is between 0 and 2. A trig equation is an equation with the variable expressed in terms of a trigonometric function. We can treat the trig function as the variable and use the appropriate methods to solve. So in the warm-up we saw that sine theta has an exponent of 1. So it's a linear equation. It was a linear trig equation. Here I see tangent, that's my trig function, and it's squared. So this would be a quadratic. And how do we solve quadratics? By setting it equal to 0, or if you're, what can I do? I can even subtract 4 on both sides and solve it like that, right? So I get 9 tangent square theta equals 7 minus 4 is 3. Divide by 9, I get tangent square theta is 3 over 9, which is 1 over 3. So I'm going to take the square root. Whenever I take the square root, remember it's going to be plus and minus. Is plus and minus 1 over rad 3, which will simplify to rad 3 over 3, right? Positive and negative. So this means what? Where is tangent positive? It's positive in the first and the third quadrant, and it's negative in the second and fourth. So all the values, I have to list all the values for theta between 0 and 2 pi, which have a value of rad 3 over 3. So what angle has a value of rad 3 over 3? It is actually in the first quadrant, it is pi over 6. So theta is pi over 6. In the second quadrant, it's 5 pi over 6. Third quadrant, I have 7 pi over 6. And the fourth quadrant, I have 11 pi over 6. So I had 4 values for theta. Example 2, it says find all solutions of 2 sine squared 2x equals 1 in the interval from 0 to 2 pi. Be careful, 2 pi is not included. It's a soft bracket, right? So what do I do? I solve like this is quadratic. I want sine squared 2x by itself. So I'm going to divide by 2. I get sine squared 2x equals 1/2. Now, I just want to find out, I want sine 2x by itself. So I take the square root. If I take the square root, I just want to put this angle. I should have a plus and minus in front of it. So I get what? Sine of 2x equals, this would be what? Plus and minus, square root of 1/2 is same thing as rad 2 over 2. So now, sine, where is sine positive and negative? It's positive in the first 2 quadrants, and it's negative in the last 2. So I'm going to list all the x values where sine is rad 2 over 2. Right, positive or negative. So I know my 2x. First of all, this 2 with x just means that you're completing, if you were to graph it, your period is now pi, or you're completing 2 cycles in 2 pi radians. That's what it means. So I know 2x is going to be pi over 4. It's all my pi over 4 family. 3 pi over 4, 5 pi over 4, and 7 pi over 4. But I'm not solving for 2x. I want to find x. So what do? I'm going to divide the entire thing by 2 or multiply by a half. It's the same thing, right? So what will happen? X is equal to pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8. Okay, now I'm going to write this. Just bear with me and I'll explain where these angles are coming from. 9 pi, 11 pi over 8, 13 pi over 8, and 15 pi over 8. Okay, I can't go further. Why am I stopping? Because 16 pi over 8 is 2 pi, and 17 pi over 8 would be a larger number than 2 pi, because my interval is only less than 2 pi. Okay, where did these angles come from? Remember, oops, I just want to write this and then explain to you. When you're cutting this in half, it doubles the interval. So here, cutting in half doubles the interval. So my interval doubles the interval, right? Or in other words, initially to sketch one cycle, you just needed 4 points in 2 pi radians. But since you're sketching 2 cycles, you'll have total of how many points? 8 critical points. I hope that makes sense, and try the problem set.